What I want to do here is replace those three forces by a single force, and I want to figure out where exactly to place that force. And I can do this. This is the other case where all of the forces are in the same direction. This is equivalent to like a center of gravity problem, which we'll talk about later in this course, where all of the forces in center of gravity would be acting downward. Okay, you can replace all of those forces down to a single force, which simplifies the problem. That's what we're doing here. Take all of these forces and break them down to a single force at a specified location and tell me what that location is. Now, the resultant force, again, is very easy. We just add them all together. They're all in the same direction. They're all in the negative j direction. 5 plus 3 plus 2. Probably should have done negative. We can all see they're pointing in the negative direction, and I get negative 10 in the j direction. Okay, so that is the resultant force. But the question becomes, where do I place that? So the first thing I'm going to do is I'm going to move everything to this location here, right? So I add them together. Then I'm going to take my resultant moment, right? So I'm going to take the R cross F. I'll draw one of them in here. I don't want to get too messy, but again, from that origin up to each one of these forces and find what moment they were creating before I moved them over. Okay, so we start with the 5, which will be 0.5 I plus 1.5 K, and that's going to be crossed with the negative 5 in the J direction. Okay, now I'll go to the negative 3, which is going to be 1.5 I plus 0.5 K, and I'll cross that with the negative 3J. Now I go up to the 2 there, which will be 1.5 I, and then 2.5K, and I'm going to cross that with the negative 2J. Okay, so quickly doing each of these cross products, again, I'm trying to find the resultant moment that's being created by all these forces about the origin that I have there. I get 7.5 I minus 2.5 K. I get 1.5 I minus 4.5 K. And I get 5I minus 3K. So adding all of those up, I get 14I minus 10K. That is the resultant moment that I have right here. Okay. And I'm going to erase that guy. So what I have here is basically a resultant force that, I don't know, it's something in that direction. Oops. Be like that. It's in that XZ plane right there. That will be my resultant moment. Again, if I think about it like in that direction, going about that axis. Okay, that's my resultant moment. Okay, but now the question becomes, okay, I'm going to place this force somewhere right there. Let me move it just so it's a little bit easier to. Okay, the question becomes, if I call this again my D vector, what is that D vector? Where do I place that force so that it creates that resultant moment? Again, the equation that we use is I take my resultant moment, take my D vector, and I cross it with my resultant vector. Now this D vector is going to be in the XZ plane, correct? So I'm going to move some amount X, some amount in the Z to figure out exactly where to place this guy. So my resultant moment that I just calculated is 14I minus 10K. My D, I'm just going to say some X value in the I direction plus some Z value in the K direction. So some X, Z coordinates that I've got to figure this out. Now cross that with my resultant force, which is negative 10J. So again, the idea is where do I place this 10 kilonewtons so that it creates that resultant moment, okay? Thereby reducing everything to a single force at a specified location, okay? So, uh, taking this a step further, I get 14I minus 10. Okay, I'm going to go ahead and do this cross product. So I get negative 10x in the k direction. That's the xi cross negative 10j. And I get plus 10z, but in the I direction. Again, that's giving me the zk cross the negative 10I. And what I do is set my i's equivalent, set my k's equivalent. So I have, 14I equals 10zi, and I have negative 10k equals negative 10xk. So from each of these, I find that x has to equal 1 meter and z equals 1.4 meters. What this is it gives me exactly the location of where to place that force, right? So this is my z direction, this is my x component. It gives me the coordinates of where to place that force, thereby reducing these three different forces down to a single force at a specific location. Again, this is similar to what we'll do when we talk about centers of gravity, in that we'll take several forces all pointing in the same direction, generally downward for center of gravity, and add them all up and find where to place a single force that gives me the equivalent external effects of the entire system.